The next thing we want to see is how can we actually predict our heat demand, or how can we implement our machine learning model in Python. In order to show you that, I have again created a small Python script, which you can find here under the name of ml.py. ML stands for machine learning. And in this file, we take the data from our database related to the heat demand. If you remember, we have the heat demand for every hour during a 1-month period, along with the outdoor temperature for that same hour, because obviously the heat demand for a district heating system depends a lot on the outdoor temperature in that district. So what we do first is fetch the data from our database, and we do it as I showed you in the previous video with using the scicopg2 library. And we also import our connection parameters from file connectionparameters.py, where we saved our host name, our port number, database name, the username, and the password for accessing our database. So we connect to the database, and then we can execute our SQL queries and fetch the data from our database. So this heat demand info will give us the heat demands and the outdoor temperatures for every hour during 1-month period. So the next thing is to actually implement our machine learning model. And for that, we will use the scikit-learn library, which is one of the popular libraries used for different machine learning models. And this time we will use a very simple model, which is a linear model and called linear regression. We also import the pandas framework because we will need it to use the data frames for our training data and our test data and so on. And we also import the plotting library so that we can just visually show our data and our predictions once we reach the end. So what we do next is we want to take the data from our database data. We want to take the hour for every instance, for every sample. And we also want to take the weekday for this date, for this particular date. So in our DB data, we have a column called date time. And from there, we can obviously take the date and we can take the hour. And for each date, we can also take some data that is related to the date, such as the day of the week. And we want to take it because probably the day of the week will also influence the heat demand for our district heating because it is not the same on a regular work day or if it is a weekend and so on. So we will take the day in the week from our date, and we will take the hour because it's not the same if it is during the day or during the night and so on. So for the inputs of our model, we will take the temperature from our database data, temperature field, and we will take the day of the week, which we just created, and we will take the hours in the day, which we also just created here. We will just transform these inputs from a dictionary to a pandas data frame so that we can manipulate this data easily. So our input data, as I already said, is a 1-month data. And for this 1 month, we have 24 hours per day. So here I decided to split the data into the training and the test data set so that I take the first 3 weeks as the training data set and the remaining days as the test data set. So 21 days, it is in fact 504 hours. So I took the first 504 samples from the inputs to our training dataset for our training inputs. At the same time, we want to create the output values, the desired heat demand for this training dataset, and we take it from the field called heat demand from our database. So in this case, we are doing supervised learning, where we know for our training data, we know the desired output that we want to get, so we can train our model with the inputs and the given outputs that we want to reach. We do the same for our test dataset. So for the test dataset, we take the remainder of the data that we have, so the rest of the days in the month, and we put them also in our X test, which is input values, and our Y test, which are the output values or the desired heat demand values that we want to reach. The next thing is that we create the model. As I already said, we will use the linear model, and from the linear model, we will use the linear regression model, which is one of the basic models in machine learning. And it is very easy to implement, as you will see. So for a very simple implementation of this model, we just create the model like this, and then we fit our model to the training input data and the training output data that we previously created. So after this line, our model will train itself so that it will get as close to the training output values by taking into account the input values from the training dataset. So after this, our model is trained, and we can see how it performs. We can evaluate if it performs as we want it. So the next thing we do is make the predictions for the training dataset by using the model predict method for, again, the same data that we used for training. So here we will get the predictions for our training dataset, and we can then compare it and calculate some metrics to see if it performs well or doesn't perform well compared to our original output data that was in the Y-train dataset. We also do the same for the test dataset by predicting the values, the output values, for our test input dataset. So this way we get the predictions for the training and for the test dataset. So in the next line, I just concatenated these two data frames so that I get just one data frame of predictions so that I can plot it, you will see, so that I can plot it and compare it to our original data. Then we can also do some error calculations. For example, here I use the metrics, the mean squared error, to compare the training output values and the predicted output values. I do the same for the test dataset to predict, to calculate the mean squared error for the test outputs and the predicted test outputs. I think that it's always easier to understand how our model performs if we can show it visually. Sometimes it is not possible, but in this case we can show visually how our model performed if we plot the data that we got as our predictions. Remember, this is the concatenated, the training and the test data set. They will be on the same graph. And we will plot the predictions, and we will plot our original output values for the heat demand, so we can see how our model performed on one plot. And after that, we again connect to the database, and we call a stored procedure that we have in our database, which is called add heat demand prediction, which will store our predictions in the heat demand prediction table so that we can access our predictions after from Ignition or from any other software that we want to use. In the end, of course, we have to close our connection to the database just to clean up the code. Okay, so I will run this. File. Okay, and we can see after the model has been trained that we get this plot where the blue line is the original heat demand, and the orange line is the predicted heat demand for every hour in our data set. So first 504 samples were the training, and the rest is the test data set. And we can see that more or less our predictions are following the trend of the heat demand, but maybe it is not performing perfectly because there are, as you see, these peaks in the original in our training data, and the model didn't succeed completely to reach every peak of the heat demand, but more or less it follows nicely the trend of our heat demand. Of course, depending on the problem that we are solving and the requirements that we have from our clients, we need to assess if this is a good model fit or it is not a good model fit. If it's not adequate, we need to test out some other, probably more complex models and see if we can get a better model fit. But maybe for some cases, we can just say that this fit is okay for our application and we can use the model as is. So after that, our code will just finish. Okay, so we also, if we want to check on our error metrics, we can print the error for the training data set, the error for the test data set, or do some different metrics as required by our model and our specific application that we are using this for. So in the end of this file, when the code is run, we get the heat demand predictions written to the database, to our table heat demand predictions, and the data is there to be collected from Ignition.